Hello world. I am Server Lesky, and in this lesson, we will make this mobile application that can read, create, update and delete records using Amplify DataStore. Amplify DataStore provides a programming model for leveraging shared and distributed data without writing additional code for offline and online scenarios, which makes working with distributed, cross-user data just as simple as working with local-only data. One of the most difficult tasks in developing web and mobile applications is to synchronize data between devices and perform offline operations. Ideally, when the device is offline, your customers should be able to continue to use your application not only to access data, but also to create and modify it. When the device returns online, the application must reconnect to the backend, synchronize the data and resolve conflicts, if any. Correct handling of all extreme cases requires a lot of undifferentiated code, even when using the AWS AppSync SDK cache on a device with autonomous mutations and delta synchronization. Amplify DataStore provides persistent storage on the device for recording, reading and monitoring data changes if you are connected to the internet or offline, and also makes it easy to synchronize data with the cloud and between devices. Amplify DataStore allows developers to write applications using distributed data without writing additional code for an offline or online script. You can use the Amplify DataStore for offline use in local-only mode without an AWS account, or provide the entire backend using AWS AppSync and Amazon DynamoDB. The data store includes Delta Sync using your GraphQL backend and several conflict resolution strategies. Advantages of AWS Amplify DataStore over Redux, MOPS, Apollo, Relay, Selectors. Comparing AWS Amplify with Redux, MOPS is not correct, since AWS Amplify is not only a state manager, but also a client server, so in the client server class we will compare it with Apollo and Relay. 1. Real-time out of the box. I don't think that a business can be considered serious if his mobile application is not affected by subscription events implemented using WebSockets technology. And how many applications nowadays work on WebSockets? I think not, due to the fact that real-time is an additional work of developers on the back and front end. For us, full-stack serverless developers on AWS Amplify, real-time goes out of the box, both on the front and on the back, and we need to write an implementation code for integrating WebSockets for each model, since it is generated automatically, as well as writing documentation for all of our generated code, implemented in our project based on the GraphQL schema instruction. In order not to scare with big words, I will show you an example from the last lesson, how store is defined in AWS Amplify. This determines the model in the store, not only for the front end, but also for the back end. One source of truth for front end and back end. Yes, I see that I will repeat it more than once in my life, since this is a killer feature in Punchline versus Redux, MOPS, Apollo, Relay. It is this architecture, which is different from Redux, MOPS, Apollo, that erases the line between the back end and front end, and puts AWS Amplify DataStore over everyone. If you are from the back end, then you no longer need to write resolvers to the database and drag subscriptions to each data model. Serverless, this is when the back-end developers came to learn the front end, as their services are needed exclusively for projects that do not keep up with the times, and from which they do not live real time. 2. Code generation. What is code generation? You can read without me on Wikipedia, unless of course you know its meaning, which in this punch reminds us of yourself. Use fetch or Axios. By sending requests to the Deep Forest API, which we also write in conjunction with Redux, MOPS, Apollo, Relay. So here is another news of the day. You no longer need to write these API calls, you only need to call them. This means that you no longer need to create this rather big daddy with the server request code, since in AWS Amplify DataStore they are also generated in your project based on your store, defined by the very same GraphQL diagram of their first item. And this is filled with one command, amplify codegen model. As a result, we get the models folder with the generated code. And the GraphQL folder after pushing to the server, with all the request and flow, TS or vanilla JavaScript. 3. Offline data and cloud sync. No need to write additional code to send a request to the server after the application is online. Sometimes you find yourself in an unreliable situation, but you better wait longer than obviously fail the operation. Apollo has Apollo Link Retry, which provides exponential rollback in server requests between default attempts. True, he, currently, does not handle retries for GraphQL errors in the response, only for network errors. Redux, MOPS, of course, does not have this solution under the hood, since they are not clients and you have to use third-party middleware, because REST is like a retired grandfather with the support of any grandchildren. AWS Amplify DataStore has not only an analog of Apollo Link Retry, but also a built-in and customizable familiar programming model with automatic version control, conflict detection, and resolution in the cloud. Among the disadvantages of AWS Amplify, I want to mention that Apollo hooks with its loading and error out of the box reduce the amount of code written on the front. How much does it all cost? With AWS AppSync, you pay only for what you use with no minimum fees or mandatory service usage. You are billed separately for query and data modification operations, and for performing real-time updates on your data. This provides you with transparency and a low price regardless of your workload type, because you only pay for the specific AWS AppSync features you use. Query and data modification operations. Query operations enable your app to fetch data and cache it locally. Data modification operations enable your app to create, update, and delete data. $4 per million query and data modification operations. Let's move from theory to practice. In the first step, we plan repositories where everything is already installed. Go into it and install the dependencies. Register your AWS account. This step is for those who do not have AWS account. Register using this instruction and check out all 5 steps in the video tutorial. Initializing AWS Amplify in a React Native project. We initialize the project with the amplify init command. We answer questions, the name of the project, then the name of the working environment. Choose your code editor. Then the JavaScript. React Native. Path. Build. Asks us to use AWS profile, we say yes. The project began to be initialized. Waiting for some time. We connect the authentication service. We select the default configuration. Then select email so we will authenticate through it. Done. We have added an authentication plugin. Now we need to push it into the cloud. Here we are shown the status of creating, that we are just creating this service with you. Click yes. AWS Amplify creates a CloudFormation template, which in turn creates a user pool cognito, customizes it based on our settings, adds libraries and files that are configured with user pool id. All. An authentication plugin added to the cloud. We collect the application and check what happened. The whole project has come true. Authenticate, enter your email. We receive an authentication code. We confirm. We are all logged in, and now if we update the application, then we are automatically transferred to an authenticated user. Check sign in. Everything was decided with this step. The next step, we connect the dependencies. We connect AppSync with you. We execute the following command: amplify add API and answer questions. We select GraphQL, then the name of the API. Be sure to select Cognito in this field, because we will work with you with the data store, authenticated users. Do you have an annotated GraphQL schema? No. Do you want a guided schema creation? Yes. Here we are offered several schemes. You can choose any. Anyway, we will replace it now. Do you want to edit the schema now? Yes. Next, paste, copy our scheme and replace it with the standard one. That is all. The main components of the data store are object types, which are a type of object that you can extract from your service. For example, job is the type of a GraphQL object. It is a type of a GraphQL object type. Type with some fields. Most types in your schema will be object types. ID, position, rate, description, owner of the field and the job type. This means that these are the only fields that can appear in any part of the GraphQL query working with the job type. GraphQL comes with a set of default scalar types out of the box. Int, 32-bit signed integer. Float, floating point value with double precision. String, character sequence UTF-8. Boolean, true or false. ID, scalar type ID is a unique identifier, often used to retrieve an object or as a key for the cache. The type of identifier is serialized in the same way as a string. However, the definition of it as an identifier means that it is not intended for human perception. Our model contains two directives. Model, object types marked with model are top-level objects in the generated API. Objects marked with model are stored in Amazon DynamoDB and can be protected with auth, linked to other objects via connection. Auth, authorization is required for the application to interact with your GraphQL API. API keys are best used for public APIs. The auth object types annotated by auth are protected by a set of authorization rules that provide you with additional controls than top-level authorization in the API. You can use the auth directive to define object types and fields in your project schema. When using the auth directive for definitions of object types, which are also annotated with a model, all recognition tools that return objects of this type will be protected. For more information about these directives and other existing directives, see the special documentation in the GraphQL transform section. We all keep our model. Model generation. Modeling your data and creating the models used by the data store is the first step to getting started. GraphQL is used as a common language for JavaScript, iOS and Android. For this process, it is also used as a network protocol when synchronizing with the cloud. GraphQL also supports some features, such as auto-merge and AppSync. We generated the src/model folder where you can see the generated code. Next, we need to update the API, because we connected the data store, generated the models, and now we need to associate the data store with our API. To do this, we call the Amplify Update API command. Select GraphQL. Enable data store for the entire API, linking them to each other. It remains to make changes to the cloud. Please note that the same table can be called with the Amplify status command. She tells us that we have two services connected. These are their names and operation. Operation of services without change and creation. Select yes and set it. Choose the code generation language target. Enter the file name pattern of GraphQL queries, mutations, and subscriptions. Enter. Do you want to update all possible GraphQL operations, queries, mutations, and subscription? Yes. Enter maximum statement depth. Increase from the default if your schema is deeply nested. Enter the file name for the generated code. Updating resources in the cloud. This may take a few minutes. The process of publishing to the cloud and the innervation of our API has begun. We all sent the service to the cloud and move on to creating the front end. Jobs main screen where read operations will be performed. We create it. Let's analyze the screen in more detail. In the view layer, we have a flat list where we pass the array of objects, which we get from the useState hook through an update job call, where we pass our received mass via the data store query call, where we pass the job model. What is a data store query call? Querying data is always against the locally synchronized data, which is updated in the background for you by the data store sync engine when connected to the cloud. You can query using models as well as conditions using predicate filters for finer-grained results. Next, we create the job detail screen so that when clicked we can see the details. Here from route params we get our line and draw it in the CRUD vacancies component. Next, we create the job add screen, where our main functions will be performed: create, update, delete. These are all the methods. What is our job add screen? We have 3 inputs. Then the update and delete buttons. 1 input, 2 input, 3 input. 3 buttons: update, delete, create. The data was received and transmitted to on submit. where we call update job or create job, depending on what we are doing the update or creation. If create job, then we call create job and pass our parameters to it. This is position, rate, description. In this case, assembled from 3 fields. Next, in the create job, we call the DataStore save method, where we transfer our object. What is the DataSafe method? Read the official documentation. To write any data to the DataStore, you can pass an instance of a model to DataStore save and it will be persisted in offline storage. At this point you can use it as an item in a normal data store, such as querying, updating or deleting. If you choose to later connect to the cloud, the item will be synchronized using GraphQL mutations, and any other systems connected to the same backend can run queries or mutations on these items as well as observe them with GraphQL subscriptions. Update job. Immediately I suggest reading the documentation in order to understand everything. Models in DataStore are immutable. To update a record, you must use the copy of function to apply updates to the items fields rather than mutating the instance directly. We get the object through a call DataStore query. We pass the object job and ID. Pass the response to the function copy of and save DataStore save. Similarly, the delete function, delete job, we get through query and delete. With the removal, everything is simple. We received our object and deleted it. Call, method, DataStore delete. Copy code and paste into the file job add. And we create the file in index.js in the job screens. Where we export the components we created and connect them to the navigation. Navigation. Open our app navigator and add our navigation screens to jobs. Step 13. Add the jobs button so that we can go to the jobs screen. To do this, edit the authenticator user index.js file. We assemble the application and check how our application works after authentication. Create a vacancy. I already remembered the field so as not to waste time. Create a record. The record was created on one device, but it seemed on another without pull refresh. These are the subscriptions that are implemented on our job main screen in the use effect hook. How it looks like a subscription and unsubscribe. Let's see in the documentation what stands for DataStore observe. You can subscribe to changes on your models. This reacts dynamically to updates of data to the underlying storage engine, which could be the result of GraphQL subscriptions as well as queries or mutations that run against the backing AppSync API if you are synchronizing with the cloud. That is, any changes that we make in our application. For example, try to update. As you can see, there was an update on all devices, as well as deletion. If we delete a record, then deletion occurs on all devices. Now we will check the work offline. What we will do for this. On the right is my phone, on the left is a simulator. I turn on airplane mode, the internet is not available with us, and I will delete the entries. As we can see, the record on the simulator is not deleted, so that it leaves, you need to go back to the network, remove the airplane mode and wait for synchronization. Everything worked. Performance offline, dates spent. Done. If you liked the video, then you can share it with your friends, like, subscribe to the channel and support the release of new episodes for Patreon. Welcome to collaborate.